Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. I am Hanifah Radha binti Abdul Razak and today I would like to present about our group project of Advanced Traffic Engineering. And we are from section 1, group 4, and our group member consists of 5 people, which is first Akifah Nakin, second is Afifah Radia, next Nur Amelia Fazlin, Nur Husnina binti Muhammad Razi, and lastly is Nurul Farisha binti Hairumani. And our lecturer name is Dr. Basil. Okay, moving on to the next and the first chapter of the project, which is introduction. Okay, the street capability is partly determined by the time of the signal, geometric aspects of the facility, and traffic structure at the facility. A traffic signal effectively divides time between rival traffic flows vying for the same space. The distribution of time has a significant impact on the operation and capabilities of the intersection and its approach and the land category's capability must be the highest hourly rate at which vehicle will actually be needed to drive through the intersection under current traffic, roadway and signaling conditions. And also at the signalized intersection, the quality of the level of service is described in terms of control, geometric, traffic and also incidents. The LOS can be calculated by using stop delay.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nursina Binti Marazi. So for today, I will explain about methodology. So for 2.1, we have determination of saturation flow S, 2.2 determination of Y value, 2.3 determination of total lost time per cycle L, and 2.4 we have determination of optimum cycle time CO. So first for 2.1 determination of saturation flow S, saturation flow is the maximum flow that can cross the stop line of the approach where there is continuous green signal indication and a continuous queue of vehicle on the approach. Saturation flow is expressed in the passenger car units per hour. So for this part, we have a no on-street parking and on-street parking. So for the no on-street parking, we have a width more than 5.5 and then width for less 5.5. So for the width more than 4.5, we refer as equal to 5 to 5 width. Whereas for the width less than 5.5 we will refer to the table 2.1. So for the on-street parking, W is reduced by the LW. LW, we will use this formula where Z is a clear distance of the nearest parked car for the stop line, which more than 7.6 meter, and then a K green time in second. So this is the table that we will use to determine the saturation flow. This is a table 2.1, relationship between effective lane width and saturation flow. Table 2.2, correction factor for the effective of gradient Fg, and then correction factor for the effective of turning gradient Ft. And then the last one is table 2.4, correction factor for turning traffic. So for 2.2 determination of Y value, we will determine the Y value, which is the ratio of flow to saturation flow. The Y value for the phase is the highest Y value for the approach within the phase for the whole junction. So we need to use the formula, and then we will get the YI, and then we use these formulas to find the yi, which is the highest y value for the approach within phase I. So 2.3 determination of total lost time per cycle L. We will use this formula where I is an integral time between phases, which equal to R plus A, and then we will use this equation to find the whole equation. And then to the 2.4 determination of optimum cycle time CO. Optimum cycle time CO is the minimum average delay for the intersection, but this delay is not greatly increased if the cycle time vary within the range of 0.7 to 1.0 of the calculation CO. So this formula we will use to find the optimum cycle time. So that's all from me. Thank you.
I would like to continue methodology. My name is Nora Farisha binti Hairumani. My metric number is AF190155. For the determination of signal settings, the effective green time, the green time plus the change interval minus the lost time for a particular phase is known as the effective green time. The total effective green time, cycle time minus total lost time. For optimum condition, G1 equal to Y1. The actual green time, G equal to G plus I plus R. And the controller setting time, K equal to G minus A minus R. The next one is delay and the formula and level of service. And the last one is the layer of the intersection. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Emilia Fazim binti Zaidi, metric number AF190011. Next, I will present 4.1 for our result analysis, which is performance of signalized intersection. So there were 6 steps. So for the first step, determination of saturation flow, which is S. So first thing for the east, for the adjusted SE, I got 1484 PCU per hour, and then for the west, for the SW, we got 1448 PCU. Next, for the north, for the adjusted SN, we got 1504, and for the south, for the adjusted SS, we got 1590. And then we move to the next step, which is determination of Y value. So we have 4 phase, and then we got the Y, which is 0.72. And then for the step 3, determination of total lost time per cycle, which is L. So since Y less than 0.85, so we can proceed the timing calculation. So, and we got the total lost time, which is L, which is we got 16 seconds. And next, for the step 4, determination of optimal cycle time, which is C. For the practical capacity Y, we got 0.78, and then we go through the optimal cycle, which is 103.57 seconds. And then next, for the step 5, determination of signal setting, and then we got total effective green time, which is 124 seconds. And we got for the G 139 seconds. And next, step 6, determination of delay and level service for each lane. So we got for the LOS, which is for the first is we got F, F, E, E, F, F, E, F, D, D, E. So thank you.
Next, I will present about the result analysis of our group project, which is improvement of signalized intersection. First step is we need to calculate the saturation flow, and this is our value and the calculated saturation flow. And next is step 2, determination of Y value. The number that we have calculated just now, we insert into this table and calculate all of it, and the total number of Y that we have calculated is 0.72. And step 3 is to determine the total lost time per cycle, and the total lost time is 16 seconds. And step 4 is to determine the optimum cycle time, and the optimum cycle time that we have calculated is 124 seconds. And next step is step 5, which is determination of signal setting. The total effective green time that we have get is 108 seconds, and this is all of the calculation. And also next, which is the last step, step 6, which is the determination of delay and level of service for each lane group. And the LOS for phase 1 is EFE, and phase 2 is EFF, phase 3 is EFD, and the phase 4 is DED. And this is the table that we use to calculate the total level of service by using the delay, and C, which is 124 seconds. And I think that's all for me. Thank you.
Good day, my name is Akifananti bin Faris. Today we're going to discuss about enhancing the level of service LOS in signalized intersection. There are many different ways to improve the LOS in the signalized intersection, and one of them is optimizing traffic signal timing, intersection design, advanced traffic management technologies, and capacity expansion. Enhancing LOS in signalized intersections creates a safer, more efficient, and sustainable transportation network. Optimized signal timing, intersection design, advanced traffic management technologies, and capacity expansion all contribute to improved LOS. Reduce road congestion, enhance safety, improve mobility, and a better quality of life other outcomes. Let's prioritize LOS improvement for a more efficient transportation system. So increasing the green time for this project, We got the delay after the improvement is 623.832 seconds, which is less than the delay before the improvement, and the difference we can observe is 9.57%. So for the LOS change, only one phase that changed the LOS, which is the phase 1 is left, changed from E to F.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noversha binti Hermaini. My metric number is F190155. I would like to present about discussion. The data shown indicates that the data were gathered at a 4-paced signalized crossroad where the entire number of cars was recorded within an hour. Two groups of lanes, one each on the left and right, make up each pace. During the busiest times of the day, the data was counted every hour with a 5-minute interval. For the Class 1, motorcycles, Class 2, cars, Class 3, van and small lorry, Class 4, big lorry and bus. In discussion, the saturation flow at pace 1 is larger than that of the rest pace, and since the effective green time was calculated such that the predetermined number of movements could occur, it is this fact that accounts for pace 1's longest effective green time. The ideal cycle duration has changed from 140 seconds to 103.57 seconds, which is better than the previous value of 140 seconds. This modification may make sense given that psychologically, people lost focus after 2 minutes of waiting. Thank you, that's all from me.
Last but not least, for our conclusion, first, a road junction is a place where vehicle traveling in several directions can do so in controlled way that reduce accident. And then it's recommended that fully actual signal be erected in this crossing to be better control traffic flow to increase LOS. As a result of the improvement, the level of service was still unsatisfactory and there were significant delays. And then a road junction with two or more roads either meets or cross at grade is known as intersection. Designing intersection which the intention of reducing accident and improving the traffic flow, so the loss could be increased to loss C to prevent traffic congestion. It is advised that the traffic signal setting be altered differently during the daytime or peak hours than in evening or at night. Thank you.